Hello, everyone, and thanks for joining us. My name is Ikjot Saini, and I'm steering committee member at ACE. ACE is a global community of machine learning practitioners and researchers who have gathered around topics in AI research, engineering, and products. We have a repository of YouTube videos that showcase authors presenting their research and practitioner demonstrating the use of emerging machine learning methods in the field. We also host social events where you can get a chance to network with fellow community members. We conduct workshops focused on helping participants take machine learning concepts from foundational theory all the way to fully developed models. We have multiple streams organized around specific topics, and presentation today covers the stream of cybersecurity. We encourage you to subscribe to our YouTube channel and check out our website at ai.science. Over to you, Abdul.
Thank you, Ikjot. Hi, everyone. My name is Abdulrahman Sathar, and I'm also steering committee member at ASIC. Today, we are hosting Roshan Singh. Welcome, Roshan. Roshan Singh received his diploma in computer engineering from Central Institute of Technology, Kokrajhar, in 2016, and a BTech degree with first class in computer science and engineering in the year 2019. Currently, he is an assistant project engineer in Open Source Intelligence Laboratory at the Indian Institute of Technology, Guwahati. He is also a certified elite in blockchain architecture and design from the National Program on Technology Enabled Learning, India. His research interests include blockchain technology, IoT, intelligent transportation systems. He has published various papers on blockchain and IoT security in various journals, including IEEE and Springer. His work, Managing Smart Home Appliances with Proof of Authority and Blockchain, won the second Best Paper Award at I4CS Conference, Germany 2019. He has also done multiple book chapters and magazine publications, including IEEE ComSoc. At present, in open source intelligent laboratory, he takes on the task of distributed processing of complex networks. So before I turn it over to Roshan, I will briefly share with you the motivation for his talk. Blockchain, which started with Bitcoin, is now being actively explored for smart contracts, which eliminates the need for a third party, improving process transparency and streamlining processes in asset management, distributed supply chain management, healthcare, network slice brokering, and computation offloading in 5G Edge. Additionally, it also has the potential to improve the quality of analytic systems by reducing data and information silos. On the other hand, IoT market, which is projected to reach 1.6 trillion USD by 2025, is rife with high-impact devices for biometric cybersecurity scanners, autonomous farming devices, asset tracking systems, etc. Security, data trust, transparency, scalability, and interoperability are of paramount importance of deploying IoT devices at scale. I am glad that Roshan is bringing blockchain and IoT together in his talk and will be addressing how blockchain can help IoT with some of these issues in his talk. Being at TELUS, this talk is personally exciting to me because of the role telcos can play in cybersecurity analytics in the IoT world, and I'm really looking forward to this talk. To the audience, please post your question in the chat, and we will be asking your questions immediately after the presentation. So I will turn over to Roshan Singh. Take it away, Roshan.
Yeah, thank you so much, Abdul, for this nice introduction. So, hello everyone, it's Roshan over here. So today I will be presenting my talk on the applications of blockchain technology or the blockchain to the IoT security. So I hope in this pandemic time everyone is well and good, and this talk will bring new areas of interest and bring a new direction in the research, also as to the topics that are being discussed in the AISC, or the AI society. So let's go forward with the talk. Today in this particular talk, we will be discussing about the topic of the applications of blockchain to IoT security. So for this talk, I will be going to introduce briefly to what is IoT, what is blockchain, and what are the challenges that the blockchain is capable to solve in the IoT domains. So no need to mention extra for the IoT. IoT itself is a self-explainable thing, where the IoT stands for the Internet of Things, where the things are itself are connected to each other in order to share the information, so that the entire performance of the ecosystem can be enhanced in some one way or another. So the applications of IoT, it varies from domains to domains. So IoT has marked itself in a number of domains over the time, such as the smartphones, autonomous vehicles, wearable, and the healthcare. So a smartwatch, say, that you are wearing is able to get your information of your pulse, heartbeat, and tells you that whether you are breathing excessively or you are breathing low. So these are some fascinating applications of IoT. Now, let us go into a understand what is this IoT architecture. So most of the things in our IoT domain, they are centralized. Centralized means the whenever I say centralized, it is the decision making process or the decision making authority for the particular IoT. So this is the centralized architecture that you can see. So in the centralized IoT architecture, we have the things. So these things are the minute entities in the IoT architecture. The things basically your cell phone, your smartwatch, your smart oven, the sensors that are being deployed in the car, or the sensors or the information systems in in your television, smart television, say per se. Now, in these things, these all are corresponding in this things section. Now we have the network infrastructure. So this network infrastructure facilitates the information sharing among these things. So the information shares has been are being undertaken in the network infrastructure. Coming to the next, the gateways allow you to communicate with the other networks in your IoT system, and the cloud infrastructures help you for the computation tasks. So in this centralized architecture, all the information are going to this particular cloud, and the data is being processed here, and the result is given back to your device. So this is the architecture of the centralized, which is mostly used, but there are some of the characteristics that we need to see that will also help us to formulate that what is the problem in the centralized architecture as such. So the centralized architecture, the device authentication, which is a critical and a crucial component in IoT networks and the IoT deployment, is your device authentication. This device authentication is in this architecture is your central, it is something in some sense it is centralized. That means your device authentication authority is a centralized body which will be authenticating your device. Second comes your access control. Your access control is again centralized, that whether to allow a particular device to interact with another device, it is also decided in a centralized manner. Coming to this revocation and registration. So what is revocation and registration? Once, say, in your IoT network, you find that some devices are misbehaving or some devices have gone out of order and are hacked. To say some in some sense, now you want to revoke this particular device from your IoT network. So how you are going to revoke? So that decision making is also now centralized. So this creates some of the challenges. So what is the challenge? What if the central authority as such goes away? Or what if the central authority is become unavailable or go down? In such a scenario, if the central authority as such is going down, you are not able to process your data and the decision making process is on halt. So that is at no sense desirable in an IoT system. So another problem is that the user have a limited control over his data. So this data we are going to the cloud for processing, say, and the user has no idea how this data is going to be processed in the cloud. So there is a lack of transparency or from the user side, from the cloud side, that how the user data that the user is producing and this particular produced data is being consumed at the cloud end. There is no clear transparency on this. Second comes the lack of assurance against availability of the services. Say whatever I have said just earlier, that if the central authority goes down, so there is no way to give the service to the devices. The third is the lack of incentives to the user. So this is a critical point. The lack of incentive to the user in the sense, say, I am using a device, I am generating the data, and now the data is going to the cloud side, and there are and behind the scenes, the cloud services how they are processing my data, I have no idea. But the thing should be going in this particular way is that I am creating the data. I should be incentivized for any analysis that is made on this data. Nowadays this cloud service provider, they are operating over this data, they are generating a huge revenue, but very little amount of revenue, or say even no revenue is no portion of that particular revenue is credited to the user. So that is a thing, like if the producer is producing but he is not getting anything out of that for his data being utilized by the third parties. This is one of the challenges. So coming to the next challenge as an IoT system deployment is that the lack of standardization of the IoT devices. So different manufacturers, different vendors, they have different standardization, that the devices are unable to work together That is not there is no common platform among these IoT devices, so that these IoT devices can work upon one particular thing. Secondly, is that most of the IoT devices, they have no privacy assurance. Privacy by default, the vendors most of the times they overlook this term of privacy. So they don't consider privacy. Instead, they consider performance over the privacy. So in order to achieve some performance goals, they put privacy on stake, and that is most of the time happening of the privacy breach, several type of attacks and all. So the third point it is coming to the picture is that there is no inherent common platform for data sharing among these devices. So as earlier I mentioned, due to various standardization issues, there is no common platform, so that this particular IoT devices they come together and they share their data and to enhance the ecosystem as such. So we are lacking over there. Now again, we have a common and number of attacks on the IoT system. This is another thing that I want to mention. So ransomware, if with proliferation of IoT, your IoT is everywhere, even in your smart home IoT is there. So say what happens if your smart home is infected with with some ransomware, it has locked into a room. It is a very critical scenario, right? So ransomware it is also gaining a lot of potential and getting a lot of exposed to attack in the IoT networks. Coming to the remote code execution, it is also one of the attacks where the remote level code is malicious code is executed remotely to the IoT system to havoc the system. So coming to the DDoS, there was one very popular DDoS attack in the past, and it was one of the it has created a history for attack like the Mirai botnet attack we call it, and it is known as the Mirai botnet attack worldwide also. So the attack infected around 600,000 IoT devices, as it targeted mainly the IoT devices and the embedded systems, and their major targets were the caption security bot, OVS, a domain name system, and a cloud hosting and a hosting provider. So and some of the major gaming servers they were the target of this particular botnet. So just briefly, we will look how this Mirai botnet works as such. So the Mirai botnet works by searching for the vulnerable nodes in the network. So for that, it uses TCP SYNC flooding. So by the TCP SYNC flooding, it finds the vulnerable node, and for finding the particular vulnerable node, it uses some predefined set of username and password. So this username and password are those username and password that are by default hard coded into these devices. Say a manufacturer is having one set of username and password that is default to all the devices, and say now for IoT deployment someone has bought this particular device and has not changed this particular device username and password. So that is a potential scope that this particular device is a bottleneck in the system, and as such it can be hacked, and the entire network is on a stake. So the Mirai does something like this as this only, that it is first finding out the devices that are very vulnerable in the network. It is getting that information. Now that particular information is being passed to the report server. Now the report server is initiating a malware loader that will be loading the malware specific to the device. Say the device is having an ARM processor, so the malware is malware corresponding to the ARM processors that will be loaded to the particular device. At the same time, that information will be passed to the bot master. Now the bot master can give the control to the command and control center. This command and control center basically will launch the attacks on the victim. So this attack is also now very much user defined. Says what type of attack the user want to do. Basically, on what resource it is going to attack. Basically, the web system or any other IoT resource it is going to attack. So that is being decided at the CNC. So in this particular way, the Mirai botnet works, and it was such a really it was creating such a havoc in the network, and it was really a problem some time back. And one of the important characteristics of Mirai botnet is that whenever you reboot your system, the Mirai goes away. So that is the magical thing about the fascinating thing about this Mirai. So this Mirai is one of the problems that was creating really a havoc in the network a couple of years back. Now, the data essential blockchain to help us to security assets. So let's see how we are going to use blockchain in this course, and in blockchain how it is going to improve the security. So first, let us see this. So why devices are common platform for secure data exchange. So in the last slide, I just mentioned that there is no common platform among data for data sharing. There is no such common platform for data sharing among the IoT devices. That was a problem. So now blockchain can provide a common platform to all the devices so that they can share the data and the data can be processed and a better result can be obtained. So this is a platform provider blockchain can act as. Second, eliminating the dependence on the central authority. So again, the central authority was creating a major bottleneck in our work. Like when the central authority goes down, the entire decision making capability is gone away. Now that is not going to happen anymore with the blockchain. The decentralized decision making capability, blockchain can come into the picture to enable us to make a decentralized decision making. Yes. Third, automating the decision making process with the help of smart contracts. Now, smart contracts are again a bunch of codes that are being deployed on the blockchain specific to a business logic, which can act upon the data on the blockchain and can initiate some actions in as such. Say, like you are paying some, you are transferring some money or some account, some amount of like coins to one of the account, and this particular account being credited with that coin. Now it can initiate some action in the IoT domain so that the device can actuate. Basically turning on and actuating a particular device in the network. So let us see in brief what is the blockchain about. So the definitions we will going through very fast, and we will just looking over them. What is that, and the key points basically in these definitions. So first definition says that a blockchain is a growing list of records that are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and a transaction data, generally represented as a Merkle tree. So in this particular definitions, the key point to note is that cryptography and the Merkle tree. Cryptography, it is the base of that particular blockchain. The entire blockchain security and the entire blockchain working is basically dependent of the cryptography. Thus, if the cryptography itself is not secure, then there is no such meaning of using a blockchain. Second, the Merkle tree, it is going to help us in the integrity of the transactions. So whenever these transactions are coming to the network, they are being formed in a block. Now this block, there will be a Merkle hash that will be basically calculated all the transactions coming to the network, and it is a upside going tree, and at the end of the tree there will be only one hash. So that is the base for basically for your integrity check. Now we have another a second definition of blockchain that says a blockchain is an open distributed ledger that can record transactions between two parties efficiently and in a verifiable and a permanent way. So here the key points to notice is that open and distributed ledger. So the blockchain scenario in the public blockchain such as the Bitcoin or the Ethereum, the entire network is open. So one can come to the network, one can participate in the network, one can be in a part of the network, and whenever the person or the entity wants to leave, he or she can leave the network without a permission from anyone. So such is a open distributed ledger. Second is the verifiable and permanent. Verifiable in the sense every transaction in the network or in the block, it is publicly available. So one can be a client, one can verify the entire record of transactions that are present from the genesis block to the block till date. So it is a verifiable. Anyone can come, anyone can verify the transaction. Being the permanent, by permanent we means it is like every time it is accessible, and the records in the blockchain, it is not going to be changed. So there is no such way. Theoretically there is way that you can change the records, but for that you require that you need to have to redo all the work that has been done from the past to till date, but practically it is not feasible. So coming to just fundamentals of the blockchain, what blockchain cryptography and how this infrastructure is going to create a blockchain. So the base of the blockchain is a public key infrastructure. So let's look into the public key infrastructure, how it facilitates the confidentiality. In the public key infrastructure, we have the public key as well as the private key. The public key is the public to all, and the private key is the private to the particular entity. Say allies want to send a message to Bob, the message M. Now what allies will do is that she will encrypt this message M with the public key of Bob, and will transfer this particular M dash to the Bob. So M dash is the encrypted message. At the end of Bob, the M dash will be decrypted with the private key of the Bob. So this private key is specific to the Bob, and this is not available to anyone else in the network except Bob. So the Bob is going to decrypt this particular message and obtain the original message. So this particular mechanism, it preserves the confidentiality of the message. That means only Bob can decrypt the message sent by allies, and no third party can access the message. So one extension to this public key cryptography is the concept of digital signatures. So what is happening in the digital signature is that instead of sizing the message with Bob's public key, the message is being signed with the Ali's private key. So what is happening is that, say the message M, so this message it is hashed with a function H. So let's briefly look at what is a hash function. Sorry, hash function basically is a function that takes a variable length input, and that function converts that variable length into a fixed length output. So this fixed length output is a deterministic output. That means whenever and in how many times you are going to give the message M to the hash function H, it is always going to give you a deterministic fixed value of a string. So what is happening here is that the message M, the original message M, it is going to be hashed by the function H. So this is required to consume less bandwidth while transmitting. So thus the data range will be reduced to some particular set of strings only. How many big your data you are giving the data, the size of the data, it is invariant of this your hash value. So this hash of the message is now going to be encrypted with the Ali's private key and being transmitted over the network. So in this case, the message M along with its encrypted value M dash is going to be transmitted over the network and being received by Bob. Bob is going to do decryption over M dash. So while doing the decryption over M dash along with its public key of Ali's, it is going to get the H of N. H of M is the hash of the send message. So what basically is having here is that whenever Alice is sending a message, she is signing with her private key. That ensures that this particular message is being signed by Alice. So it is preserving your it is like preserving your non-repudiations. Like a sender cannot deny that I have not sent this particular message. The Alice has sent a message. Now she cannot deny that I have not sent the message because the signature is made by Alice. So coming to the blockchain consensus, blockchain being itself a distributed system. How the nodes in the system reach a consensus. So let us briefly with the proof of work concept. Say this is a network where the transactions are coming in. There are nodes that are calculating over these transactions. The blocks are being formed. So these transactions are coming in the network. The miners in the network, they are mining. Say we have got two miners here. Both these two miners, they are mining, and say this miner has mined a block, this one, and this miner has mined a blue one. Now what will happen is that both of the miners has to propagate the block in the network. So both are propagating. So the miner which will propagate the block first, and all the nodes in the block all the nodes in the blockchain that are mining and that are full nodes that are verifying the blocks have received the block, and now they are verifying the block. And what will happen is that the decision to keep the block will be made only after the next block will be coming to the network. Say this particular node has kept its own block, this particular node has kept its own block. Now they will be racing again. So the block which will be next calculated by this particular miner being propagated in the network, and this particular miner being propagated among the network. So the block will be added the next. So that decision will be made by the condition that the most of the nodes in the network are going to pick up on one of the blocks. So the longest chain is going to the survive at the end of the day, and the fourth chain will be will have to converge the longest chain by dropping the found blocks. So that is the scenario. Say this particular uh, miner has mined the block and propagated the block in the network, and this particular block is now committed to the network. So upon committed in the final change, upon some more blocks are being added to the next of the 104. The 104 will be now one of the blocks that are finally committed on the blockchain. So this is how the blockchain works. So coming to our work on blockchain and IoT, and how this blockchain is going to provide security in the IoT domain. So just we are going to look into this cases, and for that, I will be going through some of the works that I have done with my team and the other members with my team and collaborating from my institute and all. So we are going to map this to our talk of the presentation of the topic of the presentation, that how blockchain is going to provide IoT security in IoT domain. So for this, I will be referring to three of my works. So let us go one by one to them. So first work is the managing smart home appliances with proof of authority and the blockchain. So this work basically was presented at the iPhone CS 2019 conference, Germany, and backed the second best speaker award. So the key contributions of this particular work was for proposing a blockchain-based home appliance management framework, and we performed a testbed experiment and compared our results with two of the consensus algorithms, and I will be talking which consensus algorithm to choose and why to choose the reason behind that. I will be discussing all those things. So let's go into that. So this was the framework that we proposed for our work. So in this framework, what was happening is that in our so let us understand first that what is the problem in a smart home scenario. So the same problem exists. The central authority, if the central authority is failed, that then you have no hope to work. Like whenever you are in a home, you now want to log now. Your digital log is logged. You need a central authority to open that. You request your cloud service provider, but the cloud service provider is not available now. What you will do? You are locked in your room now, right? So for that scenarios, blockchain can help now. Now, what we have proposed in our work is that we have proposed a framework that is basically we have our smart devices in our home, like the smart TV, that our smart lights, thermal sensors, smart AC, and so on. We are running this on the validator nodes basically, and now we have also some of the things that are highly computational, that are reaching the computation power, such the personal computer, CCTV system, or the fire alarm system. So they are somehow connected uh, with such systems that can perform some complex analysis and complex computations in regards with the thermal sensor and all. So they are much powerful from these sensors. So what will happening is that we are proposing to form a blockchain at this level, at your validator nodes level. So at the validator nodes level, we ran Ethereum blockchain, that a permission and private instance of Ethereum blockchain we ran, and we performed experiments over that. So one of the experiments that we did was like, say, consider a scenario in your smart home, that you are in your smart home, and again this particular framework, it is facilitating the work of sensor data fusion. So different sensors data, they are sensing the data, and they are writing their data onto the smart contract, and based upon your smart contract you can come to a collaborative decision. Say the example I'm going to provide that we have done in our experiment 2 is that, say you are in your home, and you have got your temperature sensor, and you are for the timing you are outside. Now you are entering back to your room, and the temperature sensor is sensing the temperature. Also there is one motion sensor that can sense the presence of something in your room. Now you are entering the room, both will activate, both will sense detect something. That temperature sensor is always detecting. Say it is very high temperature, now your AC has to be turned on. Now you have entered in your room, then your motion sensor will sense. Now it will check for the smart contract that whether temperature is high or not. If the temperature is high, then the smart contract will make a decision that I have to turn on the AC because it's high temperature and someone is present in the room. So that is being facilitated over the blockchain. So that was the concept, and that was the idea behind the framework. So coming to the testbed setup, we also perform testbed experiments in this use case. We found validator nodes and processing unit setup. We use the criteria for in a motion sensor. We use instead IR sensor for blocking the IR sensor and detecting something is there. Then we formed one UI to for interacting with the blockchain. Such so the entire experiment was like that. I have one user interface from that the user can turn on or turn off the lights. So say for example someone is going to the room and he wants to turn on the light, so he will click on the turn on button, and finally this changes will be logged to the system. So whose account made the changes, that will be logged. So that was the criteria, and that was the thing that was working over there. Was a click on the user interface that will initiate a transaction onto the blockchain, and that blockchain transaction, this particular device is listening to here, the LED devices are listening to the particular transaction, particular smart contract, to check the values of the smart contract variables, and now the variable is set to on, so this LED is going to glow. So that was the case. This is the experimental details that we used in our experiment. Coming to the results, so this is something that we need to really discuss, is that the results. As I said, that we compared our performance of the system with two of the consensus algorithm. So these two consensus algorithms, we selected proof of work as well as the proof of authority. So we can clearly see the proof of work being a highly computational, resource intensive consensus algorithm. It is consuming a lot of CPU. So it is maximum CPU is being utilized over here. However, with the proof of authority consensus mechanism, we cannot see that much amount of competition being done, because it is less competition intensive. So highly recommended for your permission and private blockchain networks. So that was the observation that we made while performing these experiments. So the use case one key takeaways are that voting-based consensus mechanism is much more efficient in terms of resource consumption as well as the transaction acceptance time in compared to challenge response-based mechanism. Secondly, such systems enables smart home appliances for localized decision making without sending the data to the cloud service provider, thus providing a better privacy, because your data is with you only. Your data is being analyzed and your data is being consumed in with your smart home settings only. It is not going outside the smart home. It is not going to the cloud service providers. That it is ensuring that your data is with you. It is not being used by your cloud service providers. Third, it is providing a better control and monitoring of home appliance. As such, by the native characteristics of the blockchain, all the events will be logged into your blockchain. So, if so, say someone has turned on your light, now you want to find that who has turned on the light, and who has turned on the light without and what time, at what period of time he is turned on, and to the what period of time the device the light was going. So you want to find out that. So you can easily find out that because the events are being logged to your blockchain. So upon traversing the blockchain transactions, you can find that there's someone in your house, your parents or someone, your kids has turned on the light. Now you want to see that who has turned on, so the account corresponding to a kid will be responsible for that transaction. So now you can find out that who has turned on my light. So the next use case basically was the around this time. Yeah. So the next use case was the decentralized parking management. So this paper was basically a smart contract based decentralized parking management, again presented at the I4CS conference 2019. So in this particular work, we tried to make the parking management in a decentralized manner. So let us understand what is the parking management problem is that. So in the big cities, we have in the multinational in these corporate cities, we have like lack of parking slots. So a number of vehicles are more, and the parking lots are very limited. It is a factor in lot of in lot of your corporate cities. So what is the problem over there is that you have to roam here and there for a parking lot. Even though centralized parking systems are there, but they are highly dependent. You have to depend upon the centralized parking system for your data. The second problem is that if I have a parking lot at my home, I'm not a parking lot owner. I don't have a large parking lot, but still I have a parking lot at my home, and I have a space for parking one vehicle, but I don't have my own vehicle now. So I will now, how can I monetize this particular space? So that is the problem that we also wanted to address. So with blockchain, we provided the facility to an individual that he can be a part of the blockchain. He can allow that he can put his empty space, his parking lot on a public blockchain platform where everyone can see that area, that this parking lot is available for the parking and can be used, and can be and by paying to the owner of the parking lot, so the customer can avail the service. So in this line, we also propose one framework for that. So in this framework, what is happening is that a car is searching for a parking lot. So he's going to call the blockchain for available parking lots in his area. So now the available parking lots are and its status is going to be given to this vehicle, that this is the parking lot and this is the charge being charged. This is the charge being charged by the parking lot owner. So now now this vehicle is the driver is going to book that lot. So that booking will be going to the blockchain as a form of transactions. That transaction is going to be mined, and that mined transactions will create event on the smart contract that this particular this particular vehicle has booked this parking lot. So now the vehicle will be approaching to the parking lot. There will be a sensor deployed on the parking lot, and it will be reading the ID of the vehicle, maybe say as a RFID information. So it is going to call the blockchain and find that, okay, is this vehicle the right vehicle who has booked this parking lot? If yes, this parking lot barricade is going to open, and the vehicle is going to park into the parking lot. And upon when the vehicle is going to come back with the parking lot, that amount of the that amount of time that he has spent in the parking lot, depending upon that time and depending upon the rate that owner is charging, the entire amount of the payment amount is going to be calculated. So before booking the next lot, the owner has to pay that amount to the owner of the parking lot. The vehicle owner has to pay the amount to the parking lot owner. So that is the scenario over here. So this is again the experiment we conducted over that. And in this case, again, we perform a transaction from the UI that, and the booking lot here, the ID of that parking lot will be parking lot owner, the PGM ID is going to be provided over here, and the user is going to initiate a book now operation. So that is going to correspond with the booking of a parking lot if the parking lot is already available. So the third use case that was, and it is very much popularized in this world with the blockchain, is the vehicular insurance. So we often hear there are a lot of frauds in insurance, and vehicular insurance is also not spared from these frauds. In order to solve this challenge, we propose again yet another work, that is a blockchain-based approach for user-based insurance in ITS. So intelligent transportation system, where we propose to depend upon the user-based insurance, not on the traditional based insurance. So there is a difference between user-based insurance and the traditional insurance. So in the traditional insurance, the insurance premium are calculated depending upon your age factors, like whatever the age of your vehicle and how much you have driven over the year. But this user-based insurance, it is a bit different, and that basically depends upon the way that you are using your vehicle, whether you are rash driving your vehicle, whether you are crossing the traffic lights, this illegal crossing of traffic lights, and so on. That how you are using your vehicle. So based upon your usage, your premium is going to be calculated. So we proposed and implemented or evaluated a pay how you drive system, a pay insurance policy for pay how you drive, and users-based insurance and incentives. So we also incorporated some logics to give incentives to the user, and the this entire approach was the telematics with the blockchain. So now let's just briefly discuss this architecture. So this was the proposed architecture by us. Like we have this legal authority. The legal authority is responsible for your legal investigation. Say just you made a hit and run case, and you want to investigation. There will be the traffic authority over here. So this traffic authority, what the responsibility of traffic authority is that whenever a vehicle is coming to the traffic authority, it is going to register the vehicle. So upon register, a set of permanent keys pair will be allocated to this particular vehicle. So once this vehicle is allocated with a permanent set of key value pair, that that key value pair will be that key is basically the public address. The address of that particular key associated to this particular vehicle will be locked onto the private blockchain. So now we have two concepts of blockchain here. One is the public blockchain, and another is the private blockchain. So this private blockchain, the associations are only with the traffic authority and the issuers in the region. So we will be discussing what is the issuer. So let us go in this way, that the vehicle is approaching the traffic authority. It is being registered with the traffic authority. Now the traffic authority is having it is allocating some key value pair that is recognized by the public address of the vehicle. So this public address, it is going mapped to this blockchain. Now whenever the traffic whenever this particular vehicle is moving on the road, he is going to come in contact with different issuers in the regions. Like these issuers are geographically separated. So whenever a vehicle is passing through the road, it is going to come in contact with one of the issuer. Now he will be requesting the issuer with his public address that allocate me some set of temporary address for communications. This issuer is going to check this private blockchain that whether this particular vehicle is registered or not. So if registered, this issuer is going to give this particular vehicle some set of key value pairs or some set of addresses to be used as a blockchain transactions. So this is being done to preserve the privacy of the vehicle. So it is not directly mapped with the original address. It is being directly mapped with the temporary addresses, which are temporary, and this mapping is only known to the traffic authority and this issuers. So now there is also the insurance company. So insurance company will be much interested in the events of the vehicle. Say this particular vehicle is doing a lot of transactions such as the harsh braking and the rash driving, and also corresponding to that, those event transactions will be generated and will be put onto the blockchain. And now the insurance company can have a look onto these transactions to find out that whether the vehicle that is insured by the insurance company is like not performing well, so that a caution message can be given to the owner of that particular vehicle. So now, so now let us just have a look onto the blockchain and the SC variant. So this SC means the smart contract variants that we have used into this particular our approach. So we have considered two blockchains. One is the public blockchain and another one is the private blockchain. So public blockchain, as I have said that it is being used for the insurance and generating the transaction directly onto the vehicle transaction onto the blockchain. Similarly, the private blockchain is being used by the issuers and the traffic authority to keep the permanent addresses of the vehicles. So we have also considered four different type of smart contracts. So first is the registration smart contract. It is entrusted with the traffic authority. So traffic authority loses the data of this your vehicle that is coming to be registered, such as the registration ID, your and other such details of the owner. So it is being kept in a private blockchain only. Second one is the temporary address of the smart contract. Temporary address smart contracts. So this temporary address smart contract the mapping of the public keys of the vehicle and to the rest of the temporary address that has been allocated to the particular vehicle. Say the original, so the mapping is only known to the issuer and the traffic authority only. So the traffic temporary address smart contract will keep a track of the addresses that has been allocated to a vehicle over time. So that is also on the private blockchain. Coming to the issuer smart contract, issuer smart contract will contain all the list of valid issuer that are being provided the right to issue temporary addresses. So this issuer smart contract can will hold all the valid issuer ID. Okay. So now, wherever the vehicle will be going, it is going to call the issuer smart contract to find out the legal or legitimate issuers in this region. So the next is the policy smart contract. So this policy smart contract basically it is going to keep the information and the details about the policy issued by a insurance company or the issuer. So that is the smart contract by the your insurance company. Coming to the set of transactions, so we consider two different types of blockchain transactions in our use case. One was the event trigger transaction, and another one is the periodic update transaction. So the event trigger transaction, it is only happening when there is some trigger of event, such as the rash driving, horse braking, and so on. So whenever such events are going to happen, it is going to trigger event trigger transaction that is going to be mined up to the blockchain. So the next one is the periodic update transaction. So in case of periodic update transaction, what is going to happen is that this transaction is going to be initiated after every period of time. Okay, that particular transaction will contain the information of your vehicle status, say what was the status of your car engine, what was the status of your fuel, and what was the status of your heat temperature in your engine, and so on. So such information will be incorporated in such transactions. So this was basically the incentive algorithm. I will just briefly describe what incentive algorithm we proposed and how it is going to affect the ecosystem. So in this particular incentive approach, we consider the behavior of the vehicle. If the vehicle is driving below the some threshold limit, say it is driving below the set threshold limit by the authority, say 60 km/h, it is going to drive. If it is continuously driving below this particular threshold, then it is going to be credited some amount. Score value is going to be associated with that particular vehicle. And if this particular vehicle is crossing the threshold, say it is going at the rate of 100 km/h, so then it is going to decrease the score of this particular vehicle. So at the end of the day, the scores are aggregated, and it is checked that whether the score is greater than some cutoff limit set by the insurance company, and if it is above the score, if the score is being above the cutoff, that the vehicle is performing really well and very genuine, and it is performing very well on the roads, then the vehicle will be awarded some of the score. So this particular score will be awarded to that particular vehicle. And again, we can think of this is in some way like your credit score. Now you can now that particular vehicle owner can encase this credit score in by going to some fuel refueling station and so on. He can increase his credit score in spite of this your fuel and so on. So again, the premium will be lowered for such good behavior of the vehicle. The premium charged for this particular insurance is going to be lowered, and so on, or else the premium is going to be higher. So for this experiment, again, we did a test-bed experiment with the TA and the three RSUs, and this RSUs and TA were involved in the mining procedure and maintaining the blockchain. So there was one interesting observation, and it is often like a genuine observation, is that being the proof of authority being utilized in maintaining the public blockchain, so the entire computation it is highly resource intensive, and we can see this picture. So this is going to show us the frequency, the utilization of CPU, the heat and so on, and the power consumption. So we can see all are being utilized at its maximum. So this is clearly denoting that this approach is going to take a huge amount of resource. So this is one of the future research directions that we can discuss on, that how we are going to address such a problem in the network in our implementation. So this is the key takeaways from our use case three, that yes, power and resource exhaustive consensus mechanism can be used for maintaining the public blockchain, while a voting based consensus mechanism can be considered for the private one, like our the smart home scenario. So now coming to the future research directions, I have discussed all the works of mine in the domain of IoT, and your providing the IoT security, like providing the availability, high availability, providing your confidentiality, and your decentralization, your high yeah, like trust among the untrusted parties such as the insurance company, and your driving or your vehicle owners, and your similarly your uh, parking lot owner, as well as the drivers as the vehicles owner. So we are providing the blockchain for this establishment of trust over this untrusted set of parties. But yes, the blockchain is not it at its mature stage as such for the proof of work consensus algorithm being considered, because our IoT devices, they are very much resource constrained and running the computationally intensive and power consumption with high power consumption consensus algorithms like the proof of work, it is not going to scale well. So we have these open challenges to what designing efficient consensus algorithms for the IoT scenarios, developing approaches for efficient data storage, because whenever we are talking at the B2B or the ITS, intelligent transportation system environment, number of transactions are going to be very high in comparison to your financial system. So our financial system public blockchain is itself very slow, and how we are planning to address this challenge. This is also an open challenge, and if this particular challenge is somehow solved, so there can be a really good scope for implementation, because data storage is something that the entire data, whatever the data is coming to your network, the full nodes are going to store your really petabytes of data will be there in 1 or 2 years, because the number of transactions is going to be very high. So coming to the device anonymization and privacy preservation. So whenever we are talking about the privacy, so it depends upon your use case to use case. So in some use cases, like we need to preserve the privacy, but the privacy has to be conditional in some sense. Now, say the vehicle has done an accident, if you are totally anonymizing the vehicle, so it is going to be really difficult for the legal authorities to take that particular vehicle. So for that particular for that particular scenario, we need a some sense of privacy preservation that should be conditional. So again, this open challenge is like how you will allow this particular blockchain that multiple parties can come together, and can utilize the data present on the blockchain to get some common results, such as the multi-party computations. So that is one of the also the research directions that we can look into. Now, coming to the recommended resources, so there are often among the community that which a particular resource is very much good, and what resources to follow for the beginners as such, because there is no limitation on the number of resources. The internet is full of resources, but what to follow for a quality learning. So these are some of the courses that I have personally followed, especially the blockchain architecture design and use cases by Sandeep Chakrabarti. That is, it is going to really give a very good brief at the fundamentals of the working of the blockchain, also the blockchain technology and applications by Professor Sandeep K. Sukla from IIT Kanpur. These two courses are really quality rich and provides a good knowledge of the topic. So coming to the references, so these are some of the references that I referred, including my papers and the papers of the Mirai botnet and so on. So yeah, that's all from my side. So back to Abdul.
Thank you so much, Roshan. That was really informative session. You covered almost all of the different variations that where we can apply it. So since blockchain, I believe it's one of the security by design principle. It follows that. So how do you see that it can be applied the way you have discussed three of the use cases? Are there more sectors or verticals that can use and can get benefits from blockchain and IoT?
Yes, yeah. There exists a couple of sectors other than the sectors that I mentioned, over the other than your home appliances and you also the ITS environment. So there are a couple of other ways like in which this blockchain can be utilized. One such is that in case of developing nations, This particular technology is going to play a crucial role with the integration of the IoT devices present in your agriculture domain. So say we have these water pumps and all. So this water wastage is lot of it's a really critical challenge in developing countries. So irrigation canals it keeps on flowing. The pipelines are keeps on flowing in one region, but there is again a drop in another region. So using IoT devices with the blockchain and ensuring and that which section of the region is using the resources and for what amount of time it has used the water body and the what amount of time the irrigation canals were open and the pipelines for the irrigation were open and was there any misuse of this water supply also, so that can be easily logged into the system at national level too if it is implemented well. Yes.
Thank you for answering that. And one of my key takeaways from your use case one was having the ownership of the data, and that's really important. Since we are going to connect so many sensors, it's really important that we are owning the data, and that will actually reduce that we are. We also need to follow principle of design principle, which is privacy by design, right? And we're trying
Right.
to anonymize devices, and I think that will incentivize it, because if we are having ownership of data and we are getting rid of centralized authority, that means we are already securing it and having data protection. Is that
Yes.
right?
Yes. Yes. Exactly.
That's right, right? So I'll turn it over to Abdul for more questions.
Yeah. Thanks, Roshan. That was a really informative talk, and I mean, I think like a lot of stuff packed into the talk, but I think like a lot to observe and really enjoyed it. So I think to me, that last use case of yours, where you're talking about insurance and collecting vehicle data was the most interesting. Like since I'm working in a telco as well, so I think like telecommunication basically can play a role over here and connection of the data. So I think I'll perhaps start with some of the questions over there. Uh, so I'll ask like some. I think I'll dive into like some details over there. So what was the point of making the issuer's blockchain private in that car insurance example? Actually, I mean, why couldn't it have been public?
Just please repeat your question once.
Yeah. So in that car insurance example, like what was the point of actually making the issuer's blockchain private? Like, why couldn't we just have used like a public blockchain?
Yeah, so yeah, yes, exactly. It's a very good observation why this particular blockchain was kept private. So as I just told in my talk also that this issuers are responsible for allocating the temporary addresses to the vehicles, and for that they need that the vehicle is already registered with the traffic authority, and that will be ensured by because the traffic authority is going to the address of the particular vehicle onto the blockchain. So now the vehicle is whenever the vehicle is approaching to one of the issuers, the issuer is going to check to the blockchain and assign the temporary addresses to the blockchain. So now, why it is kept private? So the answer for this is that the mapping should not be disclosed to the entire world. Like the public address of the traffic of this particular vehicle, what temporary addresses were allocated to those vehicles, that has to be not to be made to the public, to entire public. So yes, for say for okay, just let's let me explain in a bit depth. So this address is there. The vehicle is going to the issuers. The issuer is assigning some temporary addresses to the vehicle, and the mapping is only known to the traffic authority and these issuers in the region. So if say per se that this particular vehicle has done an accident now and investigation is being made, so the legal authority will approach the traffic authority and it will ask. So it will ask to disclose the identity of this particular vehicle who has done the accident, because this temporary address will be there and that will be not directly on the directly known to the public blockchain that this particular address is associated to which vehicle in the physical world. So and like the owner of the vehicle and so on, because that vehicle will be moving out of the scope of the road. Now the vehicle is since the vehicle is moving out of the scope of the road and this particular information is not there in the public blockchain, that the mapping of this temporary address to the permanent address, so that will be difficult. So in this case the legal authority will approach the traffic authority to disclose the identity. So this particular why it is being private is to keep also the conditional privacy for the vehicle. So am I made clear?
No, yeah, that is clear. So the issuers basically, like, I mean, do they also have access to the permanent information about the car as well? Like, because I think in your paper you talk about like the permanent credentials that the car has, which it actually gets from the TA, from the traffic authority. Like, do the issuers have that information, or do the issuers just have the temporary information about the car actually?
No, the issuers don't have the the issuers don't have the original information such as the owner or such as the ownership, direct ownership, the price of the car, the other configurations of the car. The issuer don't have such information. The issuers only have the information of the public key and whatever the corresponding private sorry whatever the corresponding temporary keys that are associated that to that particular address. So only this particular information is there with the issuer. So the ownership of the car and the other configurations of the car, that is only accessible to the trusted authority or traffic authority. So issuers has no such information about the configuration and design and much details of the car. It is only the information of the public key and it is mapping of the to the private key, sorry, to the temporary addresses. That's only.
Okay, okay. No, that makes sense. Like one thing. I mean, I'm assuming over here, like since I don't work in the insurance industry, but I'm like I would think that insurance basically would continuously be training their models, like for like using AI, machine learning, or other modeling techniques, basically based on the car behavior and the user behavior, right? So. Like does that AI and machine learning basically, like, does it happen, would it happen somewhere on the blockchain or would it happen off the blockchain? Like how would that work actually?
So yes, for our this paper, we have not considered such scenario, but yes, it's a really genuine questions because that is the your market is going on in this way only, depending upon your behaviors and the analysis made upon the behaviors of your customers. So yeah, that's a really a genuine question, and I don't think that such analysis will be good to do on the blockchain directly. So yes, the blockchain here can act as a platform for your trusted data that the insurance company can trust, so that the insurance company can trust data present over the blockchain. And now, since this data is trusted, they can run over their analysis and their algorithms over their on offload. That is not going to run on the blockchain. It's offload by being offloaded the data. They run their analysis on the data and they train their classifier or model, whatever, and they do the further analysis on that. Yes. So
Okay,
the
so
directly analysis on the blockchain is very difficult, and since it is going to take because the blockchain itself is not designed as such to allow heavy competitions on top of that.
yeah, and I think like what like one of the key points that you made over here is that the blockchain would essentially end up improving the quality of the data, basically, because it's like because of its cryptographic properties and all, like it would actually give you like good quality data on which you can actually do like AI and machine learning algorithms like off the blockchain, and that's what the direction would be, right?
Yeah, exactly. Yes.
Yeah. No, and one of the other points that sort of stood out was that your traffic authority over here basically is a central system, and as I understand, like the whole point of blockchain basically is to decentralize the process basically, and not have too much power into into one central authority, right? But over here, like the TA basically seems to own a lot of information. It seems to like have that mapping from like cars private information to cars like temporary keys and all that information. So if the TA was to basically be compromised, or if the TA went rogue, like wouldn't this system be undermined actually?
So to answer this question well, the traffic authority as such has a crucial role to play in the ITS environment. It is mainly responsible for a lot of activities such as the deployment of the roadside infrastructure and so on. So as the traffic authority also considered to be a trusted authority, because if it is going to the entire ITS scenario will be very havoc. Like there will be road accidents, there will be blockades and all, and because the wrong information will be propagating to the network. So it is often assumed in the traffic in your ITS environment that your traffic authority is a trusted entity. Now, as per the question is coming to the decentralization of blockchain. So even though by making traffic authority central, like traffic authority being a centralized entity, it is not going to compromise in any manner regarding with the centralization of public blockchain. So this public blockchain is not even going to be centralized, because it is not only the traffic authority that is maintaining the blockchain, it is also the insurance company, the OEMs, and the other entities that can be incorporated later on and in the practical scenario. So they all will be maintaining the blockchain. So it is not possible for the traffic authority to like directly divert the blockchain to its own benefits. Yes.
Okay. So I think like one of the points that you're making is that if the traffic authority was to be compromised, I mean, like it wouldn't just compromise just the blockchain itself, but a whole lot of other systems that are also dependent on the traffic authority to work properly, right? So
Yes.
like at that point, it would be a much bigger problem than just this whole blockchain mechanism is what it would be actually.
Yes. Yes. Exactly.
Yeah,
You got
yeah,
it right.
yeah. And like and I think one more question because we are over time. So I think I'll just ask my last question. Like regarding that smart home systems. Like perhaps you can switch over there. Switch to that slide. Like for your smart home system actually. Um, so
Again.
yeah. So over there, like yeah. So I think yeah. Yeah, so over there, like it seems that these processing units basically like everything, like I mean, like a lot of things are happening over blockchain, and I think one of the things that also happens in this is the central processing unit, like the processing units basically in the system, they would be instructing the devices to do something, right? Like to take an action actually, but from how the blockchain works, the devices basically have to wait like for a certain amount of time before they can actually action, because they have to make sure that this chain is a valid chain, and like it would actually be taken, like it would be moving forward, right? So they have to wait for a certain amount of time for that. So wouldn't that sort of like increase the time as to, like I mean, how soon your device can actually action, like to the command from the processing unit? uh, wouldn't that matter in this example, or?
As such, the delay will be basically in seconds. A couple of seconds will be delayed because yes, the forming of the block, it requires some time. Even though it is a proof of authority and it is a ceiling-based approach where you don't have to calculate, you don't have to do the proof of work, which is a very high computational work. But even though in the proof of authority, that will require a couple of seconds, and I think it is acceptable in the smart home systems. But going to some critical scenarios where, like in case of the healthcare, where you have to immediately turn on the sensor, otherwise the patient is going to die. In such scenarios, such delays are not acceptable in such scenario. But I think personally that such delays in the smart home scenarios can be pretty much acceptable.
No, I think that's a critical point actually. So it depends on like what problem you're trying to tackle, and the consensus mechanism that you're using basically is what it is. So yeah, I think that's all on my end as well. Like Ikjot, do we have any questions? Like any other questions? Otherwise, we wrap up or.
Yeah, we can wrap up right now. So we are good to go. So to summarize Roshan's presentation today, actually it was really intensive and having so many applications discussed in it and touching almost all the points, the critical points in this presentation. So the presentation was about applications of blockchain to IoT security. He discussed about blockchain in detail, how it's being implemented, what are some of the challenges, and with respect to IoT security, and we discussed about IoT as well. And then three of the use cases from parking management, smart homes, and vehicle insurance. And having seen those use cases, what are the challenges which we still have? And then we discussed some of the other critical points which were not discussed in the presentation during the question answer round. So, Abdul, over to you.
Yeah, thank you, Ikjot, for summing it up actually. So I thank Roshan for a great presentation, and we thank all who joined us online. To see more free content like this, visit our website at ai.science and log in to access slides from this and other sessions. Also, make sure you subscribe to our YouTube channel, ML Papers Explained, to get notified about all the live sessions and other free content that we publish. This concludes our event. Thank you all for watching.